why is it we usually do think square root of x is a function? Well, it's because we're actually not defining it like this. The way you would want this to be a function is you would say the following. You would create a piecewise function. You would say this, square root of x is square root of x, square root of x when x is greater than or equal to 0, and then we'll just say it's 0 when x is less than 0. So this fixes our counterexample, or our problem we faced in the previous video. So this means that when we want to check that it's a subset, that all the ordered pairs we're about to create are subsets of the Cartesian product of the real numbers, that's going to be true. Every x in the real numbers is mapped, and every x is mapped once. So let's go ahead and give this a shot. So if we have f of x, or f of x where x is equal to 0, let me make that look way, way nicer. There we go. F of 0, that's going to be just 0, right? Because greater than or equal to 0, we just follow our typical rule here. Then we say f of 1, that's just going to be 1 because we follow that the square root of 1 is 1. F of 2 is going to be the square root of 2, which is still a real number, so we're just following this. Now let's try negative numbers. If we try something like negative 1, well, this is just going to be 0 because we're saying any x that's going to be less than 0 or any negative x, we're just going to immediately map it to 0, and 0 is a real number. And this is going to be true for all negative numbers. So if I put a negative 31, that's just also going to go to 0. So why is this a function, but just simply saying square root of x is not a function? Well, go ahead and try and draw the graph. You can't for this case that I just showed you. So when you want to draw something like the square root of x, you're going to say this, right? You're going to say it's like a graph that looks like that. Well, what is the issue here? The issue here is you can't draw the graph for this left-hand side, everything to the left of this line here. You can't draw anything. So it's because, like, even though you can draw everything on the right, think like a computer. The computer would want to draw something here, but it can't. So what do? You say, okay, well, for less than 0, it's just going to be 0. So you put a full stop here. That's going to be every point that's less than 1, including 0. Sorry, less than 0 and 0 are all going to map to here, and everything else just goes on. So you can draw this because everything is defined. But because in the original case, everything wasn't defined, you couldn't actually draw everything or graph everything you wanted to. Of course, I just forgot, we should probably check our other conditions. So it's true that we stay in the real numbers. It's true that everything is going to be mapped. And it's true that everything is only going to be mapped once, because of course, if you draw a vertical line here, it's only going to intercept one point on that line.